January 2018, Unit 6. The doubts related to this question number 1, part B and C. So in this question, the beginning of the question, a student makes a measurement to determine the density of the steel. The student has a disc made of steel and with the thickness is about 1 millimeter. He measured the thickness of a disc using a micrometer and record the following values in millimeter. What is the average? So to calculate an average, what you have to do, you have to add and divide it by the total number. So we just have to add them, and it does not appear anomalous result. All the results are equally like space, not too much difference. That's why we are considering all of the values. Maybe one of the values anomalous, like example, if it was written 1.2, then we will not include that in our calculation. So when you will add them, it will give 1.55 millimeter, the average thickness. Calculate the percentage uncertainty in value of the mean thickness. How to calculate the uncertainty in the average result, that is maximum minus, if you have a group data, the formula to calculate the uncertainty is maximum minus minimum divided by 2. Or basically, when we have maximum minus minimum divide by mean, you can also do that one. You will get the answer. So what is the maximum value in this combination? The maximum value is 1.58 and the minimum value is 1.52. So maximum 1.58 minus minimum 1.52 and divided by mean. The mean which we calculated 1.55. So 1.58 minus 1.52 divided by the mean value 1.55 and into 100. This is a full range formula. If you want a half range, then it will be divided by 2. What is the answer for this? So 0.06 divided by the smallest, the average value 1.55 into 100. So this will give 3.387, or in percentage it will be 3.87%. That's a full range. But if you need a half range, like plus more or minus more, then it should be maximum minus minimum divided by 2 and then divided by a mean into 100. Calculate the mean value of a volume of a disk. So how to calculate a volume of a disk? It's pi r square h. The diameter is given. Yeah, both values are correct. Half range or full range, both are correct. Maximum minus minimum divided by 2 and then divide by mean into 100, that's a half range, like 2% more or 2% less. Or maximum minus minimum divided by mean into 100, that is a full range uncertainty. So both values are acceptable. And volume, it's a disk, so volume of a disk, that is pi r square h. So we have the diameter is given, the mean thickness 1.55 and the diameter is there 32.5 millimeter. So we'll convert that into meter and then divide it by 2. Or you can also get the final answer of, then it will be millimeter cube. So 3.14 multiplied by R is a radius, but diameter is given, which is 35.2. So we have to convert diameter into radius. 35.2 divided by 2, that will be radius. And height, average height was 1.55. So if I'm not converting the unit, the final answer will be in millimeter cube. Then calculate the percentage uncertainty in mean value of the volume. How the volume is calculated? Volume is calculated by radius square multiplied by h multiplied by pi. So we'll calculate the percentage uncertainty in R, and we'll calculate the percentage uncertainty in h, and we will add them. But what happened? The percentage uncertainty R will be twice. Why? Because it is written pi R square into h. So it means when power is there, the uncertainty will be twice. So what percentage uncertainty we get in R, that will be multiplied by 2, and percentage uncertainty in H is there, the thickness, that, and we'll add them, the two uncertainties, to get the uncertainty in volume. How to get the percentage uncertainty in diameter? And the uncertainty in diameter will be same as in radius, because that's only divided by 2. So diameter 32.2 and smallest value is 0.5. So 0.1. So 0.1 divided by 32.5, 0.1 divided by 32.5 into 100, that will give us the percentage uncertainty in diameter. And what is volume? Volume is pi r square h, or area multiplied by height. So 0.1 divided by 32.5 into 100, that will be 0.2%, 0.28%, 4%. After getting this uncertainty, because area will be pi r square or pi d square by 4. So because the diameter square is there, so percentage uncertainty in diameter should be twice to get the uncertainty in area. So pi uncertainty in diameter was 0.28, and that should be multiplied by 2. So that will give us total uncertainty in area, which is 0.56%. That is the uncertainty in area. We have uncertainty in area, and we already, the percentage uncertainty in thickness, how we can work out. This is the part where we work out the uncertainty in the thickness, like maximum minus minimum divided by mean into 100. Or if you use a half range, normally we use half range, but full range is also, that's not wrong, that will also give you the same answer. So percentage in a half range, the percentage in the thickness, so maximum minus minimum divided by 2, and then divide by mean into 100. So that will give us a percentage uncertainty in thickness, which was 1.94. So percentage uncertainty in area is there, because pi r square is area, that is 0.56, and uncertainty in height is, the thickness is there, 1.94. So we'll get the total uncertainty. But normally in exam, when the group data is there, they use a half range, so it's better you use the half range method. Then student use an electronic balance, and this 11.96, calculate the density, mass divided by volume will get the density. And there are different types of steel. The density of a carbon steel is 7,860. Determine whether the disc could be made up of steel. So for this purpose, we'll calculate the percentage uncertainty and percentage difference. If the percentage difference is less than the percentage uncertainty, you will say yes. But if it is higher, you will say no, it is made up of different type. Or you can work out the range, the maximum value and minimum value, and check whether using uncertainty, work out the maximum value and minimum value and check whether it lies with a standard value. So this was Unit 6. Any other question?